Each year, our need for information increases. From social networks to online banking, our demand for data is evolving. Each time you click like, a whole string of processes step into action, and in turn, somewhere in the world, a server processes a response. Because of this, the server industry is growing by 12% per year, demanding an extra 19% of electricity to run and cool them. This electricity is expensive and is being taxed more and more for its carbon emissions. It's estimated that the US alone spends $6 billion per year just on cooling its data centers. Some organizations are even building their data centers in the Arctic Circle to take advantage of the low outdoor temperatures to save money on cooling. But this is both costly financially and environmentally. Over the years, many ideas have been tried to overcome the problems of cooling data centers. One of the most exciting ideas has been liquid cooling. From running liquid through cold blocks to even submerging the whole server in dielectric. However, liquid cooling has since evolved. The next generation of liquid cooling enables a practical and scalable solution for full-time, free cooling in any climate in the world, and could revolutionize the data center as we know it. The next generation has got the industry very excited. It's widely known that copper is a good conductor of heat and is used to dissipate heat in server heat sinks. In some high power applications, this copper is made into a tube and filled with a liquid. This is called a heat pipe. Heat pipes dissipate heat over 10 times as fast as copper alone. Using this principle, a new electronics cooling platform called Iceotope has been developed. This platform encapsulates the server electronics within a sealed heat pipe known as a module, containing an ultra-convecting liquid. This liquid is called Novec. Novec is able to convect heat almost 20 times faster than water and is not electrically conductive, making it ideal for use with electronics.
The rack provides a fully self-contained protective environment for the motherboard blade. The motherboard blade is submerged within Novec coolant within a hot swappable module.
Heat is extracted from the Iceotope module by water channels that are cast into the design. The water used doesn't need to be chilled and can actually be up to 50 degrees C and still be effective. This means that even in equatorial regions, the platform will allow for full-time free cooling anywhere. As a byproduct, the warm output water can be used in other applications, such as building heating. CPU, GPU, MIC and many other electronics modules can be used with the Iceotope platform. The modules are all hot swappable, making them easy to upgrade and replace. And because Iceotope complies with the top end of the ASHRAE water cooling standard, the platform is ready for use within fully redundant data centers.
I mean, the cooling is right on the components that are producing the heat, the memory, the CPUs, and all the other electronics in the server. So it's a very good solution, and because you're running at a higher temperature, you can generate a higher grade of waste heat, which waste heat by its very nature we throw away, but in this case we can actually recycle that. So in that case you will actually save quite a bit of money in using this product.
The traditional approach of normal air-cooled data centers wastes large quantities of energy running air handling equipment. It's estimated that 20% of IT load is from internal fans, and a further 65% is used in air handling and cooling on a data center level. Iceotope eliminates the need for air handling, airflow, filtration and humidity control. Iceotope offers power densities 5 times greater than traditional air-cooled data centers, which reduces the amount of space needed. Iceotope operates an isolated low-pressure coolant circuit connecting to the building water circuit by redundant heat exchangers, making Iceotope infinitely scalable. This platform has already been deployed in a Swiss bank data center. Their VP said, The realisable energy and space savings would enable us to get by much longer with the resources which are currently available at the data centre, such as space, electricity and cooling. What this means for the data centre managers is they can increase the server density in their current installations, save money on their cooling systems, increase their reliability and resilience of the servers. It also means that new build data centres can be constructed anywhere in the world without consideration of the climate, reducing infrastructure costs.
The system is scalable, affordable and can offer full-time free cooling anywhere in the world.
Iceotope is truly the next generation in liquid cooling. Now the problem will be, what do we do with the data centre? Game changing.